Okay, hello everybody. Welcome to this webinar about Allas storage service at CSC. Today we are going to shortly, so first of all, I'm Kimmo Mattila from CSC, and today I'm shortly going to tell you first about what is Allas service, what is it used for, and then the hot topic of the day is the data migration from Taito to Allas, and from there on, for example, to Puhti server. So the old computing cluster of CSC Taito will be closed by the end of this year, and if you have some data there in the work directory or project directory or your home directory, you should move the data away from there because CSC is not going to move your data. And the most reasonable place where to put your data from Taito is this Allas service, which I'm going to now tell you about. So Allas is something which is new at CSC. We haven't had this kind of service before. It resembles some of the services we have been providing for a while, for example, IDA or HPC Archive, but this is a little bit different thing. And let's go first through what is this Allas meant for. So it's a kind of general purpose storage service for computing and cloud services, and as well as your local services if needed. Allas is meant for storing your data during the project lifetime at CSC. So it's a CSC service. It's linked to it needs to be linked to an existing computing project at CSC, and it's the place where you should keep the data during the computing project at CSC. So typically the time scale in using Allas is that the data stays there for several months or several years. Not forever, but anyhow for longer time than, for example, the temporary storage spaces in the new Puhti cluster will allow you to store the data. The default quota for Allas is 10 terabytes per one project. So this is always allocated for a project, not a single user. Of course, project can have just one user, but it can have several users. And all the project members share the same capacity. The default 10 terabyte quota is just the default value. If you need more space, you can apply for more. And at the moment at CSC, Allas is the place where we hope that you concentrate your data storage. So if you have a data set that needs to be available in the CSC servers and you want to store it somewhere, please ask quota for Allas, not for Puhti disks or some other service. So this is the place where we hope that you put your big material that needs to be stored at CSC. Further, Allas is independent service, so actually you don't have to even have a link to CSC otherwise. It might be that you need to save and share some large dataset during your research project, but you are not actually needing the CSC computing resources at all, but still you can use Allas because it's visible also outside CSC. So you can import data from your local or some other environment and share it whoever you want to share it, to whoever you want to share it, yes. So you can contact even with your laptop to Allas and upload and download data there. By default, we have Allas available in the old Taito cluster, in Puhti already now, and in future also in the Mahti supercomputer when it comes available. So we have clients installed in our environment, but it's not difficult to install the data to your local environment also. Install the client. And in addition to kind of using Allas through the client software, you can also make some of the areas in Allas totally public, which allows external or anybody to access the data through the normal HTTPS protocol. So meaning that you just put the address in the web browser and you can start downloading or viewing the data that you have made available to the Allas environment. Here is some technical details about Allas. The total size at the moment is 12 petabytes. It's an object storage system based on open source Ceph components. The system is in a technical way quite secure. We have multiple servers they're providing support so that when you load in data file which is called as an object in the Allas environment, the same data is put into the system into several copies. So even though one part of the storage environment would have some technical failure or breakdown, we still have other copies available from your data. However, you should notice that this is not a backup service. And that means that we are just providing a kind of storage space, but we are not doing incremental copies or backups of the data that has been put there. So if the data is lost by the user error, you accidentally delete the file or overwrite the file, or then decide later on that I still would like to have this file which was somehow removed, deleted by the user, we cannot get it back. We don't have any older copies of the data available, and even though we here say that we have 3 copies of the data in Allas, if you remove the data yourself, then all the 3 copies are removed at the same time. So you cannot, CSC itself doesn't provide you a backup for the data that you put to Allas. But however, Allas is actually a place where you can set up your own backupping system so that you will have a multiple copy of your data set in Allas in different places. The thing that this is an object storage service means that this is not a disk environment. When the data is put into Allas, it's put there as one single or set of objects which are immutable. You cannot change the data while it is there. And if you want to use the data and modify it, you first load the data to some other server where you do the actual modification, and then push an updated version of the data back to Allas. So you cannot directly modify data which is there in Allas. It's just a place where you store it. Quite often this is not an issue. You just have your kind of a backup copy or original copy of your data, and you push it to the place where you push or pull it to a place where you want to use it. But this is not kind of place where you could have a data set which is changing all the time, like for example a database which is actively being used and where the data is all the time coming and going. How do you then use Allas? Allas is not a kind of a single interface or tools to be used, but it provides a rich set of management features and assistant features which you can use to contact this service. So the main interfaces that we support are S3 and Swift interfaces, which I will discuss a little bit more later on. So as I already mentioned, the data can be moved to Allas directly from CSC computing environment and your local environment. And when you're working at CSC in Puhti in the future, at the moment in Taito, what is the typical process is that you first somehow import the data to Allas and then download it to the computing server, for example, Puhti Scratch area, where you then work with the data. And when you're ready with the data, you push the data back to Allas environment. Saying this doesn't mean that you have to do this all the time. For example, in Puhti, the Scratch area has 90 days time for preserving the data. So this doesn't mean that you, for each batch job, need to first download the data just before the job starts and then push the data back to Allas when the job ends. You can of course do so. It can be very practical, but the main idea is that you kind of keep track of the temporary directories at CSC in mostly the Puhti Scratch area, and make sure that those data that needs to be preserved for a longer time is pushed from Puhti Scratch to Allas environment regularly enough so that you will have the data available there if it's cleaned away from Puhti area. And you can access this data that you push then from Puhti or Taito to Allas also in other environments, in the web interface of Pouta environment or also with your own computer. Some terminology about Allas. First of all, storage space is provided by application to a CSC project. So your CSC project must apply for the quota by default you won't have it. You have to go to or your project PI must go to the MyCSC service, and there select the project and click there that apply quota access for my project, and that will be then granted, and then you will have the 10 terabytes of disk space available. If you need larger space, at the moment we don't yet have an automatic tool to increase the size of Allas, but you have to send an email request to CSC service desk for increasing your quota if that's needed. Then when you start using Allas, the structure of Allas is very simple and flat. You have your storage area there for a certain project, and inside this storage area you can create, or actually often your commands automatically create, things called buckets. These buckets are just kind of containers for your data objects that you put in there, and there's no other hierarchy in the system. So we don't actually have here directory structure like hierarchy system, what you are used to when you are using Taito or Puhti, for example. So the object names might look like that you have a directory structure there, but in practice, in technical level, there is no hierarchy structure. There's just the buckets which contain objects, which have a name and content. And so typically, you could think that the buckets are kind of root directories for your dataset, and objects are files. That's a good kind of approximation of the system, but it doesn't always hold. So try to keep in mind that even though this sometimes looks like a file system, it's not a file system. The names of the bucket must be unique through all Allas system, meaning that not just inside your project, but among all the users. So this means that if I would now make a project called test, make a bucket called test, no one else could do a bucket called test to the Allas environment, whether this person is in the same project as I am or not. And probably somebody has already done this test called bucket there, so I cannot even create that. I would get an error message if I would try to do this. And because of that feature, it's good to think already when you start using Allas, how you are going to name your buckets there. So it's good to have something like project number or username or some other kind of specific identifier for your bucket name, so that you don't end up in the situation where you are conflicting with other users with the bucket names. So let's say that you would start creating buckets like, for example, say case 1, 2, 3, 4, 5, and then you think that okay, you can increase it up to 100. But if someone has already reserved bucket name case 18, you cannot create it anymore, and that kind of breaks down your storage plan which you have decided. So try to keep in mind that you have to generate quite specific bucket names, even though they may look kind of ugly in some cases. Then in the buckets you have objects. So of course each object must have unique name inside the bucket, but in different buckets you can have objects which have same name. Objects also can contain metadata of the file, but by default they have quite little metadata, but you can increase that if needed. And you have to take mostly care of that. CSC has some tools which play with metadata, but we don't automatically create too much metadata about your data. But you can decide your own metadata systems on top of the metadata that CSC automatically provides for your objects. Then about how Allas is used. There's two protocols which are available, S3 and Swift, and this is actually one of the key issues to know about Allas, because we have many interfaces for this, and there is not a single right or wrong Allas user interface tool or Allas method of connection. But if you find a tool that says that this tool or method or program supports object storage with Swift or object storage with S3, then it's quite likely that you can also make this tool to work with Allas environment also. So these are kind of the two languages that Allas speaks, and you can use many tools to speak these languages to Allas. So they are S3 and Swift. From the point of view of end user, the key difference in these two methodologies is the authentication. S3 is from Amazon, and there the authentication is based on permanent keys, which can be created by the scripts provided by CSC. It's nice and easy. You can easily, once you have the configuration tool installed, it's automatically there in the Taito puhti, and you can also use it locally. Well, you can then, with this tool, create a key which allows you a permanent connection to your Allas project at CSC. And it's nice and easy, but it's a bit unsure, especially or unsecure, especially in the case of many user computers like Puhti or Taito. So this is the protocol that you should use if you are building your own web service, for example, which imports and reads and writes data to and from Allas. You, for example, run some kind of web service or something which needs to storage place to put data. Then this is nice and easy because it is constantly open. You don't have to worry about how you open the connection to Allas. But in a supercomputing-like environment at CSC, we consider this a little bit risky approach because this keeps the connection always open, and if somebody is able to crack to the system, then this cracker can continue automatically also to your Allas area because the connection is always open. And because of that, we in the CSC computing environment favor more this Swift protocol, and there the authentication is based on temporary tokens. That is more secure approach, but it's of course has its drawback in that sense that the temporary token is valid for 8 hours. So you have to reconnect to Allas every 8 hours. That's not a kind of big issue if you are doing interactive working in the CSC environment. But of course, if you're running batch jobs, which may take days to run and which may even need to wait for several days, then it's not nice to have this kind of feature. But we have some tools that you can use to circumvent this issue so that you can actually set up your environment so that the connection is automatically opened when it's needed. I'm not sure if I have time to show that, but you can find the instructions for that in our documentation. So we have these two languages, and this S3 language, S3 protocol is typically used by S3 CMD command, and Swift in the CSC environment can be used with several tools. There's a Swift native tools, rclone package, which I will be soon showing you, the Allas tools or A tools, which are CSC provided set of help scripts and tools like CyberDuck. And the one issue here to notice is that these languages are not totally compatible. They are handling metadata in a little bit different way. So if you create metadata sets with Swift, you cannot read them with S3 and vice versa. And also, when you upload data to Allas, files that are over 5 gigabytes or even smaller in some cases are split in the several objects when they are uploaded to the system. Normally, you don't have to actually worry about that at all. If you upload the file to Allas and it's split into pieces, when you download it there, the client typically automatically combines the pieces and you will get the same original data back again. However, these two protocols cannot, they are not compatible in the way how they split your data. So if you have uploaded a large file to Allas using Swift, you cannot download it with S3 and vice versa because they do the splitting of the data in different ways. So Swift don't know how to collect the original file, how to build the original file from the objects that have been created by S3 protocol and vice versa. So in the very early stage of your Allas usage procedure, you should decide that which protocol you are going to use. Are you just mostly using the CSC computing environment where you then should choose the Swift, or are you doing some local development where you need to have permanent connections to Allas, so there you could use S3 protocol. So there's a question. I cannot see. If I check the question, yes, the question is there need to move the data from HPC archive to Allas, and can I continue storing data to HPC archive? Well, I'm going to come to that later on, but let's take it now so that we don't forget it. Yes, I'm soon going to start demonstrating about how to move data from Taito to Allas, and HPC archive is not directly bound to Taito. It is at the moment available only through Taito, but it's a separate service, and it will be readable also after Taito has been closed. We don't have the details yet about how we will make it available and until which date it will be available, but it won't be closed by the end of this year. But anyhow, we now recommend that don't put any new data anymore to HPC archive. You could, of course, start already migrating your data from HPC archive to Allas, which is in the future. We hope that you use Allas for the data storage that you previously used for what you previously used HPC archive for. But at the moment, it's more urgent to move your data from the disk areas of Taito to Allas than from HPC archive, because HPC archive will be available for a longer time than Allas disk environment. So please don't put anything new to HPC archive, but first take care of the data that you have in the disk areas of Taito. Move them first to Allas, and only after that start considering how you are going to play or do with the HPC archive data. But also the HPC archive data should finally be transported to Allas. But don't worry more about the disk areas of Taito at the moment than about the HPC archive. Yes. So if you start using Allas in Taito or Puhti, what you first need to do is to make sure that your project has access to Allas. So you probably need to go to the puhti.csc.fi service. I can actually try to show it to you. So go to this puhti.csc.fi service here, and select your projects. And if you select one project here, you can see services which are available, and also services which you have access to or not access to. So this is now updating only. Let's see if I have some other project which I could, like this one. So here I can see that, okay, in this project I already has access to Allas, but if I would have a red cross here, this like here, I would need to click here and then accept the rules and then apply for access, and you would get it for your project. And note also that the project PI, once he does it, this comes available for your project, and after that also the project members must log into my.csc.fi and go to the corresponding place there and accept that they accept to use this Allas service, so that they accept the usage conditions set up for the Allas. So it requires actions from both the PI and from the other members of the project. Let's see where we be. Then we will. You can run. Let's continue with the slideshow. Yep. Once you are Puhti or or Taito or in the data Mangler, which was just announced, which is the data transfer node. I will show that a little bit later on. You first set up the connection to Allas by running module load Allas, which take in use a set of commands, what you use for Allas, and then you run command allasconf, which opens the connection for 8 hours and also allows you to select, if you have several projects in Allas, which project to use. So you don't have to have, you can use the project that you are using in Taito or Puhti don't need to match to the corresponding one in Allas. So you can use, even if you are working with data from project A in Puhti, you can still read or write this data to a project C, which doesn't need to have access to Puhti or Taito at all. And once you have gone through this phase, you should check how does the actual command works, and for that you should study the docs environment, so the new documentation of system of CSC, and there the Allas documentation. So if you go to this docs.csc.fi, you can find kind of migration guide here, then Puhti side and Allas user guide, and here you can see the kind of basic instructions. These are short instructions to most tools available. Yeah, and there was some question that is the do not remove folder feature no longer available in Puhti. Yes, in Puhti you don't have that kind of permanent areas, and we don't grant the project disks like we did in Taito. So in Puhti Scratch, it means that it's cleared every 90 days. Yes, it is. If you are not actively using your data, it will be cleaned away. So there is no this kind of do not remove or permanent storage area for large datasets in Puhti, only a small storage area for your software installation. And because of that, you should use Allas all the time to kind of have the main copies of your permanent datasets or results stored there. But it's quite flexible, and you will probably get quite used to it. In the beginning, of course, it's kind of feels like a little bit more extra work, but on the other hand, it has many benefits also. Okay, so let's come back to the presentation. Now we are checking the environment here. So you can, for example, go here and start studying how does rclone work. In this presentation, I'm going to quickly show you 2 of the tools. So there are many of the tools available also in the CSC computing environment. And as I already said, if you use it locally, you can use or try to use whatever tool that says that it supports S3 or Swift object storage connections. But now I have here 2 cases, rclone and the A commands from CSC. And rclone is a kind of a power user tool which is very effective, easy to use, and it's a good tool for moving large datasets or even smaller ones between Taito, Allas, Puhti combination. What's not so nice in rclone is that it overwrites and removes data without asking. So if you write incorrect commands, it's quite easy to overwrite or delete your data. It doesn't ask that, oh, are you sure that you want to do this, or that you are writing a new file which is overlapping an existing file in Allas environment or in your local environment. So in that sense, you have to be careful when using it. In principle, you can configure rclone using also S3 protocol, but in the CSC environment, we are using Swift protocol. And the documentation can be found here. Why does it show it? Let's see. So here's the rclone documentation. So it has commands for copying files, synchronizing, moving files, deleting files, creating directories or paths there, listing so that you can see what's inside there. And if you go with these links to the main documentation page of rclone outside CSC, then actually you will see that it has many other features too. So this is a very rich and capable tool for using Allas. So let's go a little back to the presentation. And how does this work? Well, on the other hand, R clones are kind of help tools based actually on mostly on R clone. These A tools try to kind of make some settings, assumptions, and features which are kind of normal or reasonable in the Taito, Puhti, Allas environment for CSC users. So these are mostly intended in the cases where you are working in Taito or Puhti and using Allas there as a storage. You can install these tools to your local Linux or Mac machines also, but I don't know if that's, in some cases that might be useful, but mostly these tools are intended to be used for the users of CSC computing environment in Taito or Puhti. And these tools don't overwrite or remove data without asking, and they try to automatically use packing and compression so that you don't have so many objects and so many so much data in Allas, but that the data is stored there in a kind of reasonable sized packages. So here's an example command for rclone. So rclone is typically done so that you put the rclone command, then some operation like copy to, and then you have a source and a destination, or just a destination if, for example, you do listing. So in this case, this command, what it would do is that it copies everything which is in directory case 1 to a service which is defined here. It's Allas. That will be defined automatically when you run the setup command in the CSC environment. And then you need to define yourself the bucket where the data is stored, and then maybe a beginning of the object name that will be used. And now in this case we would have, for example, in Puhti, in Scratch directory of your project, which is project 123 in this case, a directory called case 1 where you have 3 files, data 1, data 2, data 3, and with this command it will copy these 3 files into a bucket that you defined in Allas. So this bucket is now named as 123 underscore bucket, and it will create 3 objects there, each corresponding one of the files here. And okay, low battery. What you should notice here, that even though in the name we have this case 1 like a directory, it's not actually a directory, but the object name here is case 1 / data1.txt. However, rclone is often kind of able to mimic the situation so that you can make a listings where this look like it would be a directory. So this is the way how rclone does it. It doesn't do anything else for the objects by default. It just puts them as one object. It puts each file as one object to the storage area, while A commands try to do things a little bit in a different way. So now if you define for A command a directory, in this case this directory called case 1, it will by default collect the data inside the directory and put that into a one tar package, compress it with set standard, and then push that. This packaging is done in the Puhti or Taito side when you are running this command, and then this package is pushed to this Allas side. And notice now here that in this case you didn't actually define the bucket where the data goes at all. It's not necessary, because in Taito and Puhti, this tool tries to guess based on your original source directory, Scratch or work directory, that okay, this is from Scratch directory of project 123 in Puhti. So that means that I will by default use a bucket called project name Puhti Scratch for storing this data. And that's how you can kind of use these tools to mirror your disk environment in Puhti or in Taito to Allas, so that if you don't define else otherwise, it goes to a kind of a bucket and object name which corresponds the location in Taito or Puhti where you uploaded the data to the system. You can define also the bucket separately if needed, but you don't have to do it if you don't want to do it. So there was a question that how do you create the bucket? Well, with Swift commands, you typically don't need to create it. You kind of just, when you upload or download, when you upload the data and you define, for example, in the case of rclone, the bucket name, if it doesn't exist, it's created automatically. So if you go back to the previous example with the rclone, now here, this kind of first part of the path here, this 123_ bucket is the bucket name, and if it doesn't yet exist there in the Allas side, it will be automatically created when this command is executed. If it's there already, then just the object is added there into the existing buckets. Yes, timestamp of the file, I think it's preserved when you are copying it to Taito, and especially it's very well preserved if you use this put system, because here we actually by default are collecting the data first to a tar package, which keeps the original timestamps and also linkings which are not preserved by the rclone command. And so that in that sense, the tar package itself contains the timestamps and the original settings of the permissions and linkings, and then this package is pushed here to Allas, and then when you pull it back and open the tar package, then the timestamps and links are preserved. And let's then see in practice the questions how to see buckets and other things. So let's actually see soon how this will be done in practice, but still some things to think when you are starting to use this is that, okay, you should think that, okay, is it reasonable to store the data so that one file matches one object, or should you store it in bigger chunks? It depends on the case. For example, if you know that you randomly need to pick files from a large selection of files, maybe it's reasonable to store the data there as in this rclone manner where you have one object matching each file you have been storing. But if you know beforehand that you typically use some dataset as one entity, then it's also maybe easier to store the data as one entity there, so that you need to just pull out one dataset which contains then several files when you open it. Then question about should you use compression or not. Modern binary data formats don't compress too much, so not always the compression is kind of important, but on the other hand, text based formats do compress very well, like say some sequence files, so there it's reasonable. And just standard compression that the A commands are using, they don't actually take too much, it doesn't take too much time, so it doesn't, it's not a big waste of time, even though the data would not be would not compress so much. Then when you are using this Allas, you should think that who is going to use the data, because now in this Allas environment, it doesn't recognize users at all, actually. It just knows that some project member put this data here, and it doesn't have a tag or flag by default that would tell you that there is not a kind of single owner of the data. It's just, it belongs to the whole project, and anyone in the project can read or modify or delete the data that has been uploaded to the area of the project in Allas. So you should think that, okay, who is going to use this data and who should have permissions and who would be the project members. You can then share these buckets between projects so that you can have one project who owns the data and then a second project which has just only read-only access to certain bucket in this environment. Then please keep in mind that Allas is not the final storage place for your data. already in the beginning, when you are starting to do your research, you should keep in mind that what happens to your data once the project ends at CSC? When will the data go after that, or do you just throw it away, or do you move it to a service like IDA or some other storage service somewhere else? And then actually you should start thinking from the beginning that how do you actually keep track of all the data that you are creating. The Allas itself is not a kind of data management system. It's just a plain storage place, and you have to decide yourself and design yourself how you are going to keep track of the data that you have there and what kind of methods you are going to use there to manage your data and metadata related to that. So there are some questions, and yes, there are questions. Actually, I come to these questions a little bit later, and I now quickly show that how does this actually look in practice using this thing. And one thing which I'm going to show you first is the thing called Data Mangler. This Data Mangler was just created some days ago. It's a specific data transfer node, which has been our server that has been set up to help you to move your data from Taito to Allas. So this is a place where you can log in. It's I will actually show it from here. Just a moment. I will show you that here. If you go to the Allas object storage space here, you will find a migration tutorial here, and here you have the URL for the Data Mangler. So this is just replace your Taito.csc.fi with Data Mangler csc.fi, and this brings you to this service where you can run actually which sees exactly the same environment as Taito login nodes would see. Same commands, same directories are available, same users are there. The only difference between Taito login nodes and these Data Mangler nodes is that these Data Mangler nodes have a faster connection to Allas. So use these when you are moving big data sets from Taito to Allas. You can use also Taito and Taito Shell. If you have already started to use those, no, it's no problem to continue with do the transportation with those. But this environment has much more faster connection to Allas service. So it's nicer to do it, faster to do it here. So the first things that you need to do here is that when you log in is to run the module load Allas. And then run this allas-conf command. And it asks your CSC password. And if you just have one Allas project available, it will automatically use that. But you can have several projects to Allas. And now it asks, I have 17 projects in Allas. And now it asks me to select one of these. Unfortunately, at the moment, this thing cannot list the kind of real names of the project, only these project numbers. So in the beginning, you have to use my CSC to check that which project is which one, if you don't remember by heart these long numbers here. But I will now use this project here, which is the number 4, and select that one. And now what this system tells me is that I have opened connection to Allas successfully, and the connection will stay active for 8 hours. And now I can start using this tool. I can first list the buckets or the data that I have in Allas. I use 2 tools now here, rclone and atools. With rclone, I could do that with command rclone ls-l Allas double point. So here Allas refers to the Allas service of CSC, and this would now show me, oh, what's this? Oh, it's taking the backup, sorry. I take LSD actually here, it's nice. It shows me that I have there 3 buckets now available. One is called this backup, and then course backup buckets. And before going further, you can see that here is a kind of I can list what is in this course. This is from the course that we had about Allas yesterday. I can list also what is inside here if I provide this. No. Sorry, of course I have to put here this Allas. So, and it shows me what kind of objects I have here. So I have some PDF files here available and some other data. And then you can see here that there was this thing called segments. Same bucket name, but segments, which says that there's 0 something. This is the stuff which is related of splitting the big objects when they upload it there. So if you see this kind of bucket created there automatically, it means that you have uploaded some big file there, like the one I have here, this genomes.tar, which is split into pieces, and this is the place where the pieces are stored. You don't have to care about that at actually all. If you download the big file you have here, you can still use this original bucket name here, and the system will automatically collect the data from the segments file, and actually you should actually touch or modify this bucket at all. But it's, if you wonder what are these buckets there, that's the places where the pieces of big files are stored. Okay, this was how I see this in rclone with Allas commands or a commands. I could just type a list, and it would show me that I have these buckets, and if I take the bucket name here, I can put it here, and it shows me what objects I have inside this bucket. And if I would like to now, well, let's then next upload a file. I have here a directory called genomes, where I have some genome data, just some indexes for aligners. And for example, I have here a file called test. No, actually I take the zebrafish. It contains a set of files. Both are indexes for zebrafish genome. And if I now want to upload this data to Allas with rclone, there are several rclone subcommands that you could use to do that. I will now use this rclone copy to. I define what to copy, this zebrafish directory. I could just take one file, but I take the whole directory now here. And then I put here Allas, double point, and then I have to define now the bucket name. I put here something, zebrafish 123. I hope that no one else has yet used that, and now actually this should work. Let's see what happens. Actually, it doesn't say anything because by default, rclone command doesn't tell you about how the copying progresses. So it will take a while before it has copied the data over to Allas. And actually, I think I try to kill this process and put here minus capital P, so I can see what's happening. And now it's telling me that, okay, it's showing me the progress of the copying process. It was happening also after, in the previous command, but it's not. It was not shown. It shows me at what rate it's moving the data to Allas, and it's showing what file at the time it is moving there. So yeah, and now it's done. And if I now check what is in this bucket, which I created, so it was this zebrafish 123. I can see that I have these objects created over there. So that was kind of the way that rclone does it by default. You define the bucket name, and one object contains one file matches one object. Then if I would do the same thing with a commands, I could use command a put zebrafish. Now I don't define anything else. And what it actually does is it first creates locally here in the data Mangler machine a temporary file where it collects all the data from this zebrafish directory, and then it compresses it with just standard, and then pushes this compressed package to the Allas environment. This takes for a while. Let's see. Let's hope that it's not taking too long. Okay, compression rate was not great because much of the index files were already in a binary format, so they didn't compress what much, but still it compressed a little bit. And now it transports the data to Allas and confirms the upload for small files and tells me that okay, 8 files from directory zebrafish were uploaded into this bucket is as one compressed file. It is there, and if I take command a list now, I can actually see that now there is a new bucket created called this my user account project number I'm using Taito workdir. So this automatically created this bucket and put the data there. So if I now check what is inside here, I can see that it contains one object which has this kind of long name, which looks like a directory. And if I run command a info, it shows me metadata that a put command created for this file. It tells me that okay, this file was uploaded at this time. zebrafish.csc. User who uploaded it was Koike Mattil, and the host was datamangler 01, and the host name defined for Allas tools was Taito, and this was the original location, and here are the files which were in this package. I can also check this content of this directory or this bucket with rclone. rclone. And it now shows me actually 2 objects. And this a meta object is actually the metadata file that was created by the a put command. So rclone doesn't create these things, but here was actually it actually contains the data which is shown here. It's just a text file containing this data about the object that was uploaded there. So if you can cross use a commands and rclone commands, but you should realize that you should notice that these a put commands put these additional metadata files there in addition just to the plain data object to the environment. Okay, so this is the way how you do the upload to the system, and how you would then download it. It's the same thing. I have here now connection in Puhti, and if I now, let's see if I have already. Okay, I haven't yet configured the connection. So this is now in Puhti server, and if I here module load Allas, now, okay. Now notice that I have to choose the same project as I did in Taito. Otherwise, I don't see the data that I just uploaded there. So I take number 4, and it says connection is configured successfully, and if I take here a list, I can now see the same datasets. Let's, for example, say with a list the zebrafish file. Yes, I know that we are running out of time, and I think we are not able to discuss all the questions here during this time. So I now see the data that I uploaded there to the Allas, and I could just use rclone or rget to get the data back here. So, for example, if I take a list here and then define make a new directory called there, new, and take a get and this package. What it does is that it downloads the data from Allas and then does the unpacking and creates a similar directory that was originally created when the data was pushed to Allas in Taito. So now I have moved this data from Taito to Allas. This was the very brief overview about how things work. So you should study this migration tutorial. For example, here you have examples what to do and how to work in the cases where your data transfer takes more than 8 hours. There you should use this Allas-Golf -K and some other tricks to make sure that the connection is preserved while you're long data processing. And let's then see the questions if there's some questions there available. So with that, what happens with array jobs if all output, if all of them are pull or push tiers? Yes, this is something which you should be careful. I think you cannot, I'm not sure if you can simultaneously read data, but at least you cannot simultaneously write data to the same object. So in this kind of cases, it might be better to do the data download or upload before the data job starts. I'm not sure how this array job approach would work. So I would prefer so that you do the processing so that you first download the data and only that after that launch the array job. Might work also in array job depending on the case, but I'm not sure how it does. Actually, I don't know how it would went, but certainly you cannot at least write in the same object from several sources in the same time. Yeah, is it possible to copy files with no hub, or should the terminal with Allas connection to keep it open? In Data Mangler, I guess you could use no hub, but I would prefer in Data Mangler node use the screen session, which is described there in the tutorial opening the screen at the moment. So check there how we suggest that you should do the data copying process for large files which take a long time, so that you could keep the screen session running there in the Taito login node or in the Data Mangler and launch the copy process there, and then you can leave the screen session running there in the background and log yourself out from the Data Mangler, and then later on connect the same Data Mangler node again and reconnect to your screen session to see how things have evolved. And then a question: what if I need to copy a file of terabyte size? Yeah, and the data movement would take more than 10 hours. Yes, if you are, that's a good question. So the 8-hour limit is limit for starting a new process. So if you start to copy this 1 terabyte file with rclone, for example, so if it's just individual files that you need to copy, if the process starts, it will go until the end, even though it takes longer than 8 hours. It won't be cut in the middle. But if you have a list of files to be copied, a new file cannot be copied. The new copying process for the next file cannot be started if the token has outdated. But for a single file, once it starts, it's okay. It goes through. You can restart the copying with not rsync, but actually rclone sync, and it will continue from where it ends. I would be just very careful to use rclone sync commands if you are not familiar with that, because you can easily overwrite or remove your dataset if you mix the order of the source and destination there. But yes, in principle, you could then continue with the rclone sync command. And then there's a question about using Allas in batch jobs, and that's also described here in the tutorials. If you go to the Allas tutorials, there's using Allas in batch jobs, and there we once again have a kind of tricks. The A commands actually work pretty automatically, but if you want to use rclone, then you have to use these tricks, and these hopefully are not our final solution for this program, but we will hopefully be able to develop something more kind of nicer looking than this kind of source scripts that you at the moment have to put into your batch job scripts to be able to use Allas kind of automatically from the batch job. Puhti does not question about if Puhti has a home and work directory separately. Yes, they do have, but the difference is there that, actually Puhti don't have work directory at all. So there's only each user has a home directory, but that's the only kind of personal directory that user has. There's a Scratch directory, which is kind of replacing the work directory, but Scratch is owned by all project members, not just single user. Can bash scripts read data files directly from Allas? Yes, you can use rclone with cat command to read data directly from Allas if it's a kind of ASCII or, well, I guess any format. So that you can use. It's possible. Is it possible to put data copying command within the batch job? Yeah, that was already discussed and finished. The Puhti storage yes can be accessed with WinSCP, but not Allas. Can I access? Then a question about can I access my project in Puhti with the shortcut like slash? Well, you can. If you mean that, can you kind of define shortcuts to your Scratch area? In Puhti, you can define environment variables by yourself, and we are developing a tool that you could use to define a kind of a default project definition to Puhti, so that you would have an environment variable like Scratch that would be used to point directly to a certain Scratch area. But that's a little bit off topic of this webinar. Yes, and we are. Last question coming, but please you can send questions and requests to Service.csc.fi about Allas. The system is pretty new, it's still evolving, and documentation is not kind of final, so there is things happening all the time, evolving, and we are a bit in a hurry to get all the data copied by the end of this year. By the way, when you copy data to Allas, it would be nice if you would then remove it from Taito once it's copied to Allas from Taito, so that we would know where we are going with the data. Is there? Yeah. Okay. What happens with script files after 90 days? So if you want to preserve some kind of command scripts or data installations, which are not big ones, they are the Apple directory, which has by default 50 gigabyte storage size in Puhti. So you should put these kind of scripts and command and programs there, and there they will be preserved. They are not clean, but this place is not intended for data. It's so small storage area that you cannot put big data sets there. But that's the place where to put the permanent scripts and settings that you need for your project. Okay, thank you everybody. We will close the webinar now, and please be active and contact CSC if you have any questions. Thanks.